Welcome to Graphing and Simultaneous Equations, Lesson 6, Parallel and Perpendicular Lines. In the previous lesson, we were having a look at how we can check whether two or more lines are collinear. In this particular lesson, we're going to refresh our minds on the four relationships of lines, in particular the parallel and perpendicular lines. So what does the word parallel and what does the word perpendicular mean in the context of the coordinate geometry? And then secondly, we're going to have a look at how we can algebraically check whether lines or two or more lines are parallel or perpendicular. Now, jumping into it, recall the four different types of relationships we can have with lines. So the first one is the arbitrary intersection, where two lines intersect at arbitrary points. And the intersection itself, the angles are non-90 degrees. They're just two lines, they cut one another, and nothing is special about it. Now the second one is collinear. So recall, collinear lines are where two or more lines pass through all common points. Now today what we're going to look at is, firstly, we're going to have a look at parallel lines. So recall last week when I spoke about parallel lines being like train tracks. The line itself moves in the same direction like a train track, and the distance between the two lines never increases, nor does it ever decrease. They simply travel on to infinity with never touching or never intersecting one another. Now, the final relationship we're going to look at is perpendicular. So in a perpendicular relationship, that is when two or more lines, they cut each other, and the angle at which they cut is 90 degrees, as depicted by the boxes on these two lines here. So they cut at 90 degrees to one another. Now, there are checks we can make to see whether these relationships, the perpendicular and the parallel relationships, exist between lines. And the first one we'll look at is the parallel lines. So to check whether two lines are parallel or not, we inspect the gradient. So recall y equals m1x plus c1 and y equals m2x plus c2. We look at each individual gradient, so m1 and m2, and if m1 is the same as m2, then we know that the two lines in question are perpendicular. Sorry, not perpendicular, parallel. And we could also see if m1 divided by m2 is equal to 1, then we can see that they are also perpendicular or parallel. That should say parallel. There we go. So if m1 and m2 are equal, then the relationship between the two lines is parallel relationship. Now going down, consider we've got two equations here. Equation 1 is y equals 0.4x plus 2, and equation 2 is y equals 2 over 5x minus 1.5. Now I've already highlighted the gradients in these examples, and we can see that in equation 1, m1 equals 0.4 and m2 equals 2 over 5. Now what I'm going to do to see if these are equal, I'll ask myself, is m2 divided by m1 equal to 1, and if so, the lines must be parallel. If not, they are not parallel. So we'll go m1 down there, m2 here, substituting in the values, 2.5 over, or 2 over 5 over 0.4, and using the fractional arithmetic. It's 2 over 5 times 0.4, or 1 over 0.4, and getting my calculator up. 5 times 0.4 equals 2. So 2 over 2, and m2 over m1 is equal to 1. Therefore, lines 1 and 2 are parallel. Perfect. Now let's look on to example 2. State whether the following lines are parallel via the comparison of equations. So again, we will highlight our gradients of 1 over 5, so negative 1 over 5, and m2 is going to be negative 0.1. Comparing these two, so m1 equals negative 1 over 5, m2 is equal to negative 0.1, and comparing the two, we'll say m2 divided by m1 is equal to negative 0.1 divided by 1 over 5. Then using my fractional arithmetic, I can say, because I'm dividing this as a fraction, I can say negative 0.1 times 5 over 1, and then that becomes simply 5. So this becomes negative 0.5, which does not equal, shall I rewrite that? m2 over m1 does not equal 1. Therefore, lines 1 and lines 2 are not parallel. Easy. Now, going on to the next check. So recall in our learning objectives, we've proven, or we've had a look at 4 relationships, and we've algebraically proven the relationship of parallel lines. Now we want to move on to perpendicular lines. So remembering that perpendicular lines are lines that intersect, and the intersection, the angle they create, is 90 degrees. So we can prove that the intersection, or we can prove that 2 lines are perpendicular by comparing the 2 gradients of the lines and seeing if the multiplication of m1 and m2 is equal to negative 1. So using this rule here, if we go over to a question, and equation 1 is y equals negative 0.7x minus 2.9, and equation 2, y equals 10x over 7 plus 2.7. If we compare the 2 gradients by multiplying them together and seeing if we get a value of negative 1, we can see whether the lines are perpendicular or not. So firstly, I'll highlight the gradients of negative 0.7 and 10 over 7. So m1 equals negative 0.7, m2 equals 10 over 7. And now I'm going to multiply these two together and say m1 times m2 equals negative 0.7 times 10 over 7. And negative 0.7 times 10, well, that's simply 7. So 7 over 7, and 7 over 7 is equal to 1, so it becomes negative 1. So m1 times m2 equals negative 1, and remembering the rule for checking if they're perpendicular is if this case holds, then the lines are perpendicular. So this line does indeed hold, therefore lines 1 and 2 are perpendicular. Now, question 2. State whether the following lines are perpendicular by a comparison of the equations. Let's do the check again. So this green line and this blue line refers to, or the green line refers to equation 1 here, the blue line refers to equation 2 over here. The gradient for line 1 is m1 equals negative 1.1, and the equation for line, or gradient for line 2 is 0.417. So m2 equals 0.417. Now multiplying these two together, if m1 times m2 is equal to negative 1, then we know they're perpendicular. So we'll say negative 1.1 times 0.417. And I can't do that in my head, so I'll get my trusty calculator back out. And we'll say negative 1.1 multiplied by 0.417. And that is equal to, clearly not negative 1. It is 0.4587. Therefore, m1 times m2 doesn't equal 0, does not equal negative 1. Therefore, lines 1 and 2 are not perpendicular. Bingo. Now, final question. We've got something a little bit different. The green and orange lines pass through points 0, 3 and 0, negative 1 respectively. Both lines intersect at points 2, 1. State the relationship of both lines. So notice I've got a graph over here, and we can see where they intersect. So intersection. And we want to see whether, we want to check whether they're perpendicular or not. So notice we don't have the equation to work with. We've just got a graph, and we've got some arbitrary points we've been given, and one point being the intersection point. Now, the way in which I'm going to do this is I'm going to put all of these points on the graph, and then I'm going to calculate the gradient by counting the squares, so the rise over the run. So 0, 3 on the green line. Where is that? Well, it is here. 0 and 3. And 0 and negative 1, where is that? That is over here. So, in fact, the points we're given are the y-intercepts and the intersection points. So, 0 and negative 1. Now, what I'm going to do is I'm going to calculate the gradient using the rise over the run method. So, for the green line, I'm going to go across 3, then down 2. Like so. And then for the orange line, I'm going to go up 2, then across 2. So the gradient for the green line, which I'll write in a green pen to make it easier to see, is m1 equals the rise over the run. And notice for this particular one, we went across by 2 and then we went down by 2. So it's not actually, so the run itself, that's going to be 2. But the rise, it's going to be negative 2 because we went downwards. So m1 is going to be negative 2 over 2, which is the same as it writing negative 1. Now in orange, we'll say m2 equals the rise over the run. And the rise in this case is we went up 2 steps. And to go up 2 steps, we then went across 2 steps. And therefore m2 equals 2 over 2, which is 1. Now, to check whether they are perpendicular, we're going to multiply the two gradients together, m1 times m2, and we'll see if it equals -1. If it equals -1, then we know that both of these lines are perpendicular. So m1 is -1, m2 is 1. -1 times 1 is indeed -1. Therefore, both, or I should say, lines 1 and 2 are perpendicular. So, in summary, what we did today was we went back and we had a quick review of the four relationships, the parallel and the perpendicular in particular, and then we had a look at how we can algebraically prove whether two lines are parallel or whether two lines have a perpendicular relationship.